everyone. So I'm Jason Ratcliffe. I work with Green Tech regarding my PhD with the University of Plymouth. I'm also a director of Sterren Surveyors, which are a practicing surveying firm. And hopefully today we can discuss quite a few on-topic important points regarding UVAL research and what's occurring in today's UK market, specifically around new values, and then following on to our UK legislation and any kind of research topics really, and what we've currently undertaken so far.
Very nice. Okay, so I mean, how topical is the U-value currently compared to maybe where it once was a few years ago, and how does it fit into the energy ratings overall?
Yeah, so it plays a really vital role in especially the rental market. Obviously, with the legislation now pushing the requirements up for energy efficiency performance. The issue we have with it is a lot of contractors and surveyors and overall insulators or kind of energy performance improvements rely very heavily on the findings of EPCs. Now, that's fantastic because obviously then you have a universal grading system. Now, the only issue we tend to find is they don't always, well, they're not always as accurate as they need to be or should be. This can be, this can be kind of due to a number of reasons, really.
Okay, and an EPC, what does that stand for, just for maybe the non-British crowd here?
Yeah, absolutely. So it's energy performance certificate.
Okay.
So it needs one whether it's being sold or rented.
Okay, I see. And I take it, I mean, the U-value itself is not specifically mentioned in this, but would it be more important for the higher values, or what would be the story with it?
Yeah, so it's indirectly relevant in the sense that you are looking at the performance, the energy performance of the property, which also includes the insulation and the air tightness. So the U value would be directly affected by the energy performance certificate and how that needs to be upgraded. But it also encompasses things like heating and the way that you can be using, say, solar panels and things like that. So it encompasses a bit more than U values.
Older homes clearly, let's say in Europe, are less energy efficient than the modern ones built, or theoretically anyway. And but does that mean that the modern homes won't degrade, or how does that work?
Yeah, so if we base this on a new build property being up to the specification that it should be, with the correct workmanship, then it would, in theory, be completely sort of airtight, well insulated up to current builder regulation standards, and be extremely efficient in being able to maintain a very positive, healthy environment internally within the property itself. Now, over time, you take that same building and then say in 5, 10, 15 years time, as time goes on, obviously things start degrading. You've got thermal fluctuations, weather conditions, general use and degrading of the building materials themselves. So they'll start moving, warping, slightly deteriorating or sagging, depending on the insulation or materials used. Because of those issues, that would then start causing leakages, so heat escape through the envelope of the property. And also what you'll then find is, say, heating systems will then have to work harder to maintain a comfortable living environment, and it costs more money to heat your home as it degrades over time.
I take it, I mean, yeah, the UK's weather is very similar to Ireland's, which being wet and windy. I take it that has an adverse effect as well on the rate at which the building maybe might worsen.
Oh, absolutely. Yeah, you're 100% right. In part of my research, which there's not a huge amount of at the minute, unfortunately, but we're looking to change that, is wind-driven rain, and relative humidity and saturation of the external facade. It's all very well at the beginning on a new build in when you've got sort of cladding or a completely watertight external facade of a property. However, as time goes on, that can crack or shrink and cause regress, and especially if it's untreated. Coastal properties, typically kind of within about 50 miles of the coast. It's a very rough approximation, but they tend to have increased salinity, so salts contained within the air and within wind-driven rain. So the salt itself can also increase thermal deficiency within insulation by anywhere up to about 50 to 60%. So we've seen within it can reduce it to a point where it'll actually fail building regulation standards straight from new build if it was saturated to about a 50 to 60% saturation, which isn't uncommon if it's a that's highly exposed, or if the property is being built and you get some harsh weather coming in before it's watertight. So a new build, can, and sometimes I've seen it fail building regulation UVAL compliance, even if it was signed off as being adequate, because the material, in theory, when it was fitted, is of an adequate thickness and UVAL performance.
Oh, it's super interesting. And it kind of comes back to the need as well for not just theoretical U values, but also the in situ ones themselves. What is the difference between more the practical stuff in the industry and, let's say, the theoretical stuff, which of course you're still out in the field for, that's in your PhD?
Yeah, so if you just say practicing surveyors that are looking at properties, whether it's residential or commercial, on a day in, day out basis for clients, predominantly it's for house buyers or homeowners that are experiencing relatively cold patches within properties or black spot mold, things like that. You need to have a well in-depth understanding of what may be causing that, and how you'd be able to identify a financially viable alternative based on their current conditions, and what they're looking to do with the property as well. You can't go in and start crashing down walls and dry lining if they've just done a complete renovation inside and things. So it's very client by client specific, and thermographic inspections are really, really great at doing a non-invasive inspection of a property. You can see on this one here, this was actually one I did a few weeks ago, where you've got the walls which are nicely insulated, the windows are doing their job, but then within the roof space we're looking at quite excessive heat escape. So with this particular client, we can then identify areas that will need thermally upgrading. So it's really important from a surveying perspective to understand these things, but also there's a lot of things that come into consideration, such as the orientation of the building, where it's located, if it's exposed to the elements, if there's fields, backdrops, or coastal environment, and also how they may be using the property, and also obviously what the property is made of. Now, when you're then looking from a researcher's perspective, it's not, although you've got a lot of field testing, it's not necessarily for specific application to a client or a homeowner directly. What you're looking at is the theoretical. So you're looking at a holistic view, and you're saying, okay, well, these are common factors. What happens if I challenge this? What happens if this type of material gets saturated, at a coastal environment? What happens? So you're able to do a lot more controlled testing on specific variants or variables that may go wrong. And I think the beauty of it is, because I'm lucky enough to be a surveyor and a PhD researcher, is I can look at those problematic areas from a surveying perspective, but then convert them into a lab methodology and be able to then say, this is actually we're going to look at this in much more detail, and then put it back into surveying afterwards. So it's a great kind of combination of the two.
UVAL and, let's say, energy and environmental legislation varies very much on a country by country and a region by region basis, even in some countries. So
Yes.
what's the current status of it in the UK at the moment?
So there's a very fine line between the need, or the huge demand for further housing. Obviously, we have a lack of new housing available for the current population in the UK.
Yeah, and Ireland as well. I mean, a lot
Yeah.
around Europe.
So I think it's a combination of that and being able to meet accelerated house demands, but also be able to ensure that the quality of these builds are not jeopardized. Now, the real issue on paper is, well, in actual practicality rather than on paper, is we're seeing a lot more homes, new builds that are, but unfortunately, substandard. Now, this legislation is coming in to try and force, rather than influence and persuade, contractors to take ownership of these quality control measures, and also be able to try and reduce emissions, so be able to then push more sustainable sources such as air source heat pumps, ground source heat pumps, things like that. But also from a U-value perspective, these are getting tighter and tighter. For new builds, we're looking at reducing these down to, I believe it's going down to 0.18 watts per square meter Kelvin soon, which is, or at least it's coming into effect in certain types of construction relatively soon, which is very little. And that's set to reduce even further as more.
Would that be for every building element, or would it be more for walls?
Not every building element. No, that we're talking specifically these ones. We're talking about main walls, but every building will be reducing and increasing their expectations of U values and how much heat escape is acceptable before it's signed off. Now, also going just slightly back to the EPC, they're looking at then pushing that up. At the moment, you can't legally let a residential property if it's an F or a G, but they're now looking at moving that up to a D, and then in a few years' time, also they're considering then moving it up to a C. So it's forever making it more and more challenging. So U values are more and more important sort of factors to really be honing in on.
And like, how aware are, say, the general, let's say, surveying community about U value versus other metrics?
Not as knowledgeable as they should be, if I'm going to be completely honest. I have done my fair share of discussing with various building regulation officers, energy assessors throughout the country. There are pockets of people that are experienced within U value and the importance of such, but the majority of which they lack the practical application or understanding as to why these are important, but not just why they're important, but why they're there and how they can be achieved. Most of the time, it's a tick box exercise. You put, for example, 150 mil of PIR insulation into a wall, and that's a tick box. Yes, that's fine, but that's as far as the majority of contractors and regulatory bodies they go with their understanding, really.
Yeah.
Now, a lot of this current research that I'm undertaking is to do with how the U value changes and how a dynamic approach should be taken as standard, not just as sort of a niche contractor that knows their stuff. It should be, in my opinion, within building regulations and under approved document Part L. Now, part of this research, which is a huge part, I've got a couple of big old buildings in Cornwall which are being retrofitted with various different natural and synthetic insulation. And then we're looking at how the U values change between the insulation itself, but also the orientation of the building, so that we can then put something together and say by the end of it, actually, this is important. It's not just a one size fits all, every property, every construction, and every location. We need to look at it in a lot more detail. So this is very text heavy slide, but it's really just giving a snapshot of exactly what I've just said. Again, this is kind of research that's is not really available at the moment, which is why we've had to kind of look into new ways of achieving accurate data capture. Now, on the top right, it's only obviously it's a graphic design of the cube, but for all intents and purposes, there was no climate chamber available for what I needed it for. I needed something which I could move around a building, get into a normal size vehicle and take to site and put up one person, and then be able to collapse it down, move it wherever I wanted, including through partitioning walls and things. So I came up with this essentially 1 meter cube.
For those who maybe do not interact with climate chambers, do you want to give a brief explanation there about what the purpose of them actually is?
So a climate chamber, basically in simple terms, it just regulates the temperature inside of the box, but it also regulates the relative humidity, airflow, and general moisture content within there as well. So you can put it wherever you want as a representation of a specific wall or ceiling, roof, etc., and be able to then keep that at a constant climate for 2, 3, 4 weeks, however long you need it for. Which is really important, especially, I mean, modern buildings, not necessarily, because it's a lot easier to control the temperature inside. But when you're looking at older buildings or derelict buildings, or buildings before they're renovated, it's not viable or even possible in most cases to be able to regulate that properly. So by having something like this, we can then go in and test all of these older buildings, which really then going into the green tech kind of collaboration, as it were, works very well with the green tech kits, where we've got sort of thermocouples, heat sensors fitted, and we've been seeing some really accurate and interesting results already, which kind of goes against current regulations a little bit, in the sense, it's not a one size fits all. We've started to gain evidence of that, and also the significance of coastal environments as well, which you can see on this here, on that little blurb down the right hand side, where it does vary a significant amount depending on the same structure, exactly the same walls, wall thicknesses, but just the orientation of the building can have a huge adverse effect on the thermal transmittance, the U values, and also the relative humidity. So that can link to black spot mold and lots of other things.
Yeah, I suppose this is where really the knowledge and experience of the surveyor or researcher themselves really comes into play, with using this equipment and understanding the building as a whole.
Yeah, absolutely. And this is very kind of specific for the data collection and the kind of mapping of, I suppose, a new alternative to the EPC database, which, say, the Energy House 2.0, that they're currently doing in the UK at the moment. And what we're then hoping to achieve is being able to have a set of data from doing things like this multiple times. So if you do have a self-build, or you've got a contractor, they would then be able to use this as a guide as to what to do to thermally optimize a property, rather than just meet current building regs and hope it works. Yeah, it's exciting times to be able to start doing new research that wasn't necessarily possible before, because the equipment wasn't there for research, but now it's the hard part. It's the bit where we have got to start going into a lot more buildings and start getting this data in, to be able to then say, this is what we're doing, and this is what needs to be done to achieve accurate longevity to U values and accuracy for the tools that we have.
Mhm. Yeah, because I mean, at the end of the day, I mean, say a U value measurement equipment is one tool out of an array of different tools that a surveyor may have. And of course, as I was saying, I mean, it's also down to the judgment of and the experience of the surveyor as well when it comes to the measurement and the evaluation of the overall building.
Absolutely, yeah. And it's again, it's the accuracy for ISO standards. Any data capture needs to meet these criteria, otherwise they're kind of deemed inaccurate and unusable. So things such as the elemental cube and looking at UV reflection outside and drafts and all sorts of variables come into it. And it's exactly right. It's about experience of the surveyor or of the researcher and being able to evaluate each building to make sure that the data is accurate on site.
Mhm. Yeah, it appears now that the technology is coming ahead of the legislation in this sense with what you've come up with, and then also with all of the in situ U value with the in situ U value measurement equipment as well, ahead of any sort of mandatory in situ U value measurement that's in the law.
Absolutely, yeah. And I think this will, rather than legislation leading going forward, I think because that's very much on a blanket, universal approach, which it always has been. This is very targeted, very specific, and if we can then get enough evidence behind us with this, then we can then approach building regulation standards, etc., and challenge what should be acceptable and the standard.
When you were designing the elemental cube, what were the main factors that you were looking for and that you designed the elemental cube for that say you did not see in an existing solution beforehand?
Yeah, that's a really good question. I think when I was doing a lot of research on what was available, I think there was a lot of huge, expensive climate chamber kind of setups that took up a huge amount of space, and it took a team of people to build. There was no specific commercially viable product on the market you could just go and buy off the shelf. So I had to think about my own needs of what I needed for my research. I was going into a building that was an active building site. It had no heating, there was no control over necessary power sources or being able to control the elements of what was going on inside that building, dust collection, lots of things. Plus, obviously, it needed to get to and from site. I didn't have a team of people, so it needed to be practical for just a standard vehicle. And while I was on site, I started off without any internal partitioning walls, so that was great. But then all of a sudden, you start getting doorways in place, and then you think, "But I've got to get this equipment from one side of the building to the other. How am I going to do that?" So all of these questions needed to be answered, and then that's where the 5 panel system really came into effect, where they're essentially about meter square panels that are highly insulated and durable, that clip together in an airtight box cube with wheels and integral kind of heating and cooling systems. So it gradually progressed over time, just based on what I needed to achieve within my own research.
We have a question in here saying, how do we compensate for aspect in terms of effective U value? Now, aspect, I mean, perhaps you know more of the technical terms there if it's a surveyor thing, but by aspect, is it the orientation or is it aspect ratio?
Well, I mean, both of those. So the ratio you're looking at, obviously in older buildings, you're looking at potential thermal bypass in various quantities, especially infill rubble. So a wall itself is very difficult to take a specific sort of meter cubed and say, well, this is a representation of the whole wall. So by doing a thermographic inspection prior to being able to then identify areas that may be problematic, then kind of narrowing that down to fitting the cube into a specific area, heating it for a good sort of 5 to 7 days before testing starts to ensure that that sort of high thermal mass really builds up in the wall, then taking another thermographic inspection outside to make sure that there's no pockets that are going to have adverse effects. And at that point, you can then allocate sort of where you're putting your thermal couple and things.
Okay, very nice. So there's the question was clarified to be in terms of solar radiation on the external surface to be compensated for.
Well,
I mean,
okay. So north facing typically can be absolutely fine. Most of the time you're in a lot of shade anyway, based on it being on the external facade of the building. However, south facing became quite a big issue, especially in the pilot phase. So we've come up with quite a, sorry, not really unique, but it's a cheap solution of getting a very small section of white UPVC guttering, which we then put over the top of the sensors externally. It then acts as a great ventilation tunnel. It maintains a very stable condition outside, and it also reflects UV radiation and temperatures, so it keeps it nice and stable from the outside.
Mm-hmm. Thanks for the explanation there. So I'd like to first of all wrap up on my side, saying thank you so much for coming and presenting your work, and also thank you to the audience for giving your time here to watch it.